National Electrical Code Section 126.F.1.a specifically addresses the arrangement of disconnecting means to prevent unintentional energizing. However, its application is limited to distribution-type equipment only. To understand this limitation, it's crucial to define what constitutes distribution-type equipment in the context of this code section and differentiate it from other electrical components such as transformers, uninterruptible power supplies commonly referred to as UPS, and UPS battery cabinet. Distribution equipment, as the name suggests, is primarily concerned with distributing electrical power from a source, such as a utility supply or a generator, to various loads within a facility. This equipment typically includes panel boards, switchboards, switchgear, motor control centers, and similar assemblies designed to route and control electrical power. These systems are characterized by their role in dividing a large electrical supply into smaller circuits, each feeding specific areas or equipment. They often incorporate overcurrent protection devices such as circuit breakers or fuses to safeguard against faults and overloads, and they provide a means of disconnecting power to individual circuits or sections of the electrical system for maintenance or emergency purposes. Now let's examine the other components mentioned: transformers, UPSs, and UPS battery cabinets, and why they don't fall under the purview of NEC Section 126.F.1.a. Transformers are static electrical devices that transfer electrical energy between two or more circuits through electromagnetic induction. They are used to step up or step down voltage levels to match the requirements of different equipment or systems. While transformers are essential components in electrical distribution systems, they are not themselves considered distribution equipment. Their primary function is voltage transformation, not power distribution. Uninterruptible power supplies, or UPSs, are designed to provide backup power to critical loads in the event of a power outage. A typical UPS consists of a rectifier, a battery bank, and an inverter. During normal operation, the rectifier converts alternating current, or AC, power to direct current, or DC, to charge the batteries and power the inverter. The inverter then converts the DC power back to AC to supply the load. When a power outage occurs, the UPS seamlessly switches to battery power, ensuring uninterrupted operation of the connected equipment. Although UPS play a vital role in maintaining power continuity, they are not categorized as distribution equipment. Their primary function is power conditioning and backup, not the distribution of power to multiple loads. UPS battery cabinets house the batteries that provide the backup power for the UPS. These batteries are typically arranged in strings to achieve the desired voltage and capacity. The battery cabinets are connected to the UPS and provide the DC power source when the main power supply is interrupted. Like the UPS itself, the battery cabinets are not considered distribution equipment. Their function is solely to store and supply energy to the UPS during power outages. The distinction between distribution equipment and these other components is crucial for understanding the scope of NEC Section 126.F.1.a. This section is specifically concerned with the arrangement of disconnecting means in distribution equipment to prevent unintentional energizing. This means that the requirements of this section apply to panel boards, switchboards, switchgear, and motor control centers, but not to transformers, UPSs, or UPS battery cabinets. To further clarify this distinction, let's consider some practical examples. Imagine a large data center with numerous servers and other critical equipment. The electrical system in a data center includes a main switchboard that receives power from the utility supply. This switchboard distributes power to various panel boards located throughout the facility. Each panel board feeds multiple circuits that supply power to the servers, cooling systems, and other equipment. In this scenario, the switchboard and the panel boards are considered distribution equipment and are subject to the requirements of NEC Section 126.F.1.a. The transformers that step down the voltage from the utility supply to the levels required by the equipment are not considered distribution equipment and are not subject to these requirements. Similarly, the UPS that provide backup power to the servers and the UPS battery cabinets that store the energy for the UPS are also excluded from the scope of this section. Now let's consider another example, a manufacturing plant with various machines and production equipment. The electrical system in the plant includes a motor control center that controls the motors that drive the machines. The motor control center receives power from a switchboard and distributes it to individual motor starters. Each motor starter controls a specific motor and provides overcurrent protection and disconnecting means. In this case, the switchboard and the motor control center are considered distribution equipment and are subject to the requirements of NEC Section 126.F.1.a. Individual motor starters, while part of the motor control center, may or may not be considered distribution equipment depending on their specific function and arrangement. The transformers that supply power to the motor control center are not considered distribution equipment. To summarize, NEC Section 126.F.1 applies only to distribution type equipment, which includes panel boards, switchboards, switchgear, motor control centers, and similar assemblies that are designed to distribute electrical power from a source to various loads. Transformers, OBSs, and UPS battery cabinets are not considered distribution equipment and are therefore not subject to the requirements of this section. It's important to note that other sections of the National Electrical Code may apply to these components depending on the specific installation and application. For example, Article 450 covers the installation of transformers, while Article 700 addresses emergency systems, including UPS. It is recommended to consult the relevant sections of the NEC for specific requirements related to these components. Furthermore, local codes and regulations may also impose additional requirements. It's always best to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. In conclusion, understanding the scope of NEC Section 126.F.1 is essential for ensuring the safe and proper installation of electrical equipment. By recognizing the distinction between distribution equipment and other electrical components such as transformers, OBSs, and UPS battery cabinets, electrical professionals can apply the code correctly and prevent unintentional energizing, thereby protecting personnel and equipment. The term distribution equipment refers to assemblies such as switchboards, panel boards, and motor control centers. Transformers change voltage levels. UPS units provide backup power. Battery cabinets store energy for UPS systems. Each component has a distinct purpose within an electrical system. NEC 126.F.1 focuses on the layout and control of distribution equipment. This regulation aims to prevent accidental power flow during maintenance or emergencies. Ensuring worker safety during electrical work is a critical goal of the NEC. Other sections of the NEC address the installation and safety of transformers and UPS systems. Article 450 provides guidelines for transformers. Article 700 covers emergency systems, including UPS systems. Always consult the relevant articles of the NEC for specific installation requirements. Compliance with all applicable codes and standards is essential for safe electrical installations. Local codes and regulations might have additional requirements beyond the NEC. Consulting a qualified electrical inspector or engineer is crucial for ensuring compliance. Proper electrical design and installation are key to preventing accidents. Safe electrical practices protect both personnel and equipment. Continuous learning and staying updated with the latest codes are important for electrical professionals. Understanding the specific purpose of each component in an electrical system is vital for correct application of the NEC. This knowledge aids in ensuring safety and proper functioning of electrical installations. Further clarification on the roles of transformers, UPS units, and battery cabinets is beneficial. Transformers step up or step down voltage levels to match equipment requirements. UPS units provide a seamless transition to battery power during outages, ensuring continuous operation. Battery cabinets store the energy needed for UPS units to function during power interruption. These components work together to maintain a reliable power supply, but they are not distribution equipment themselves. Understanding these distinctions helps in applying NEC requirements accurately. Accurately interpreting electrical codes leads to safer electrical systems. Safe electrical systems minimize the risk of electrical hazards. Ongoing training and education enhance electrical safety knowledge. Collaboration with experienced professionals ensures adherence to best practices. Following established procedures and guidelines is vital for maintaining electrical safety. Proper maintenance and inspection of electrical systems are crucial for identifying potential problems. Regular inspections can help prevent equipment failures and ensure safe operation. Addressing identified issues promptly is essential for maintaining electrical safety. A proactive approach to electrical safety minimizes risks and protects personnel. Investing in electrical safety measures is a worthwhile investment in protecting people and property. Prioritizing electrical safety creates a safer working environment. Safe electrical practices contribute to overall workplace safety. A culture of safety promotes awareness and encourages responsible behavior. Encouraging open communication about safety concerns is important for creating a safe workplace. Recognizing and addressing potential hazards is a key element of a comprehensive safety program. Providing adequate training and resources empowers employees to work safely. Regular safety audits can help identify areas for improvement. Continuously improving safety practices is an ongoing process. A commitment to safety from all levels of the organization is essential for success. Implementing a comprehensive safety program requires careful planning and execution. Seeking guidance from safety professionals can help ensure the effectiveness of safety initiatives. Sharing best practices and lessons learned promotes a culture of continuous improvement. Celebrating safety achievements reinforces the importance of safety. Recognizing and rewarding employees for their commitment to safety can motivate others to follow suit. A positive attitude towards safety is essential for creating a safe workplace. Focusing on prevention rather than reaction minimizes the risk of accident. Learning from past mistakes helps to prevent similar incidents from occurring in the future. Analyzing accident data can provide valuable insights into areas where safety improvements are needed. Using technology to enhance safety can help to reduce risks and improve efficiency. Investing in new safety equipment and technologies demonstrates a commitment to safety. Staying abreast of new developments in safety technology is important for maintaining a competitive edge. Integrating safety into all aspects of the business can help to create a more sustainable and successful organization. A holistic approach to safety considers the impact of safety on all stakeholders. Focusing on the long-term benefits of safety can help to justify investments in safety measures. Building a strong safety culture takes time and effort, but it is well worth the investment. A strong safety culture can help to attract and retain top talent. Employees are more likely to be engaged and productive when they feel safe and valued. A safe and healthy workplace can improve employee morale and reduce absenteeism. A commitment to safety can enhance the organization's reputation and build trust with stakeholders. A strong safety record can help to attract new customers and business partners. A safe and sustainable organization is better positioned to thrive in the long term. In addition to the specific requirements of NEC Section 126.F.1.a, it is important to consider the general principles of electrical safety. These principles include energizing equipment before working on it, using appropriate personal protective equipment, following lockout/tagout procedures, and verifying that equipment is properly grounded. By adhering to these principles and complying with all applicable codes and standards, electrical professionals can significantly reduce the risk of electrical hazards and ensure the safety of themselves and others. It's always better to be safe than sorry when working with electricity.